Okie dokie. So, applying factorials, combinations and permutations to count arrangements and selections efficiently. That's quite a mouthful. Alright, so this is probability part 2. Right now there is no probability in this section, right, but we'll build it in. For now, we're doing quite literally what is called counting techniques, which sounds quite trivial, and then it becomes more complicated and you're like, oh, okay, that's why this is useful. So, first idea. This is the 10A part. 10A part, I'm hoping that this goes like, basically you guys tell me, yeah, is that it? Because that seems really obvious. So, we've got a menu there. There are some breakfast menus, some breakfast items, some lunch items, and some dinner items. I need to make that abundantly clear, so there we go. That's the division of it. Cool. You can only have one item per meal. Okay? Yeah, anyway. You only have one item per meal. How many possible days, how many different combinations of meals could you have for any given day?
How many meals are in a day?
So I'm saying breakfast, lunch, dinner,
Yeah, cool.
right? You can only have one of these, right? So you can only have bacon and eggs, or cereal, or toast, or pancakes, as well as sandwiches or soup, as well as roast or burger or steak.
Can you have twice in one day?
No.
Oh.
Okay, so you will literally only have 3 meals in the day. Cool? How many options do you have?
24.
Okay, I've got 1 vote for 24.
I also give 24.
Also give 24.
27.
27, okay. Why stab in the dark, okay?
Oh, yeah,
Other people have no idea.
We're not 24.
You've gone back to 24, okay? You've actually looked at the problem for more than 2 seconds, okay? Cool. So it sounds like we're doing a little bit of intuitive stuff here. How did we get 24?
I saw it as like, came on how many options I can accommodate. I can do with one breakfast item, then multiply the number by how many breakfast items there were.
Right?
I got 24 from 6 each.
From 6 each?
6 times 4, 24.
6 times 4.
I got 6 combinations from each breakfast.
Is it 4 times 2 times 3?
Okay. That works. I'm curious where 6 came from.
There are 6 different combinations you can have.
2 times 3 times 4.
If you have for the one breakfast item, so like for bacon and eggs, you can have.
Oh, okay. So he's gone 4 times 2 times 3. You've gone 3 times 2, 6 times 4.
Yeah.
That's okay. Yeah. So you are doing the same thing. Good. I just didn't see 6 straight away, but you're going from bottom up rather than top down, which is fine. Works. No problem with that at all. Go. Okay. Brilliant.
Oh,
Yep.
oh. No, can you make that line longer?
Say again.
Can you make that line longer?
Can I make
There's
the...
Divider.
There's
Oh, sorry. Okay, yeah.
Dividers.
Yeah, those are breakfast items there, those are lunch items in between, but those are dinners there.
Yeah.
Oh, okay, sure. Alright. Enjoy the line. Very good. Okay, cool.
It's better than lunch anyway.
You've intuitively done something, which is brilliant. But it may or may not be obvious in certain circumstances later, or it's handy to have it in the back of your mind what you're doing here. So, when you had these 4 items, you could only choose one. So essentially, we were saying this, or this, or this, or this. Okay. And then when we had another meal, that became and, because we're having breakfast and lunch. So these count as ands. This, or that, and then a whole bunch of ors again. Great. Intuitively, you ended up with 4, 2, 3. So based on that, what are the ors mathematically doing?
Adding together.
Oh, adding.
Adding, right? Because you've got one thing, or another thing, or another thing, or another thing. Cool? So that just means that all your ors imply plus. Cool? What do your ands imply?
Multiplication.
Right. Cool. 9 times out of 10, all will mean plus and will mean multiply. It's just a handy thing to have in the back of your head for when you start to get a bit worried about, hang on, am I doing this right? Cool. So that's that. Yeah, that's all I wanted for that. That's most of 10A, is just that basic kind of thinking. Let's double check. Right. Oh, the textbook goes fancy and calls this the addition rule and the multiplication rule. It's just overkill, so it's just intuitive. Cool, that's fine. Next bit. Alright, so I've got 4 markers. Oh, I did. There we go. 4. I have 4 markers. Okay?
Yeah.
I could hold them that way, or I could hold them that way,
No.
or I could hold them that way. Right? Okay. How many ways could I hold these?
60.
Okay, I've got a 24 and a 16. Any other takers?
I'm just gonna go with 16, but I don't really know.
Okay. Is this as intuitive as the other one? Maybe yes, maybe no, I don't know. Yep.
Is it, would it not be, there's 4 markers and then there's 4 locations, so each marking can go in just one separate location.
Okay.
So I mean, instead of it being breakfast and lunch, it could be colours and locations.
Okay.
It's 4 locations, 4 colours, 7 multiplied together, you get 16.
You're so close. You've got all the right pieces and then you've just mashed them together in the wrong way. It's like getting puzzle pieces and just go, that's not how a puzzle works. You're flirting with good ideas. Let's go back a bit. Let's say I've just got, what was my first one, purple? Let's say I've just got purple. How many ways can I arrange the purple?
What?
One way.
Oh.
Right, because there's only the one. Right? It's not I'm holding it with 4 different fingers, it's just, that's that. Cool. I've got 2. How many ways can I hold that? 2 ways. Right, this way or that way? Okay, next on the screen. How many ways can I hold these?
3.
9. No.
Okay, I've got 3, 6 and 9, so we've got all multiples of 3, that's nice. Okay. Something happened between here and here that made things less trivial. Okay, well, let's be really annoying and write down all the combinations of these. Or all the permutations of these, I should say. So I'm just going to write P's and B's and G's. Cool, that would be one permutation. Okay. Now, I could just randomly pick another set, but if I start randomly wandering around, it's just as easy that I miss one entirely, and it's possible that I double up without realising. So it would probably be a good idea to do this systematically. How would you suggest doing that? Yep.
Moving one to the side, one to the side.
Right. So only move one set at a time. Seems like a good idea. Okay. You can keep any of them constant and it'll still work, but I highly recommend keep the first thing constant. Right? Do you guys know binary numbers? How you go?
1, 2, 4.
I go, let's just say, I start with 0. Right, I'm just going to pick 4 bits here. Okay, the next number is 1. What's the next number? 2. How do I write it? 0, 0, 1, 0. Cool. How do I write 3?
0, 1, 2,
1. How do I write 4?
How do you do this?
Okay. We'll go a couple more. Alright, so what am I? This is 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. What's happening?
You're going through the combinations.
Right, I'm going through the combinations in a systematic order. Right, so 0, 0, 0 is true. Right, I'm going to start on the right. So I'm going to change the thing on the far right first. Cool, that becomes 1. Alright. After that, well, I can change this thing. Right, because I can't change this anymore because all I've got is 0s and 1s and that's already use all the triple zeros and 0, 1. Okay, so now I need to change the third thing. Okay, I'll bring this back to 0. Okay, great. Next thing, all right, I could just increment this by 1. Great. If I try to increment this again, I go back to 0, and I've already got that, so I need to change a new section. And so on and so on and so on. Cool, cool. So you're always changing the rightmost thing, unless you've already got that combination somewhere.
What if you finish all that and it goes 1, 1, 1, 1, 1?
Then you're out of space.
Can you go?
So that'll be up to 31,
Yeah.
right? Which gives you a surprisingly long list for just 4 bits. Right? And it ends up being powers of 2 for every extra one you chuck on. Right? But that's the way that I find is helpful to think about these things, is you just start on the right and then just start incrementing until you've already exhausted that, and then move the next one up, and then increment, go back to the start. And then increment the right until that's exhausted, then increment the next one. And so on and so on. Alright, so, for this. And different people think about this different ways, so don't be beholden to me. It's just, I find that handy. Cool, so I can't change green to something else without using up that other thing, so these are going to switch places. Cool, cool? Okay, can I change these two again without repeating myself? No. So I'm going to have to change this guy. You're free to pick whichever one you're going to change it to. I'm going to choose to put blue in there because I'm kind of trying to make green as right as possible. Cool, I'm trying to make green as right as possible. So purple comes through. Okay, great. What would be my next selection? I'm going to go blue, green, purple. Cool. So I've moved it across one again. Great. Can I change the back to it all?
Just green. Oh, brown.
Brown? What? Don't have brown.
No, I meant, I thought you meant put green in the front.
Right, green in the front is the only next move available, yeah? Okay, green in the front. Cool. I'm defaulting to having purple as high as possible, so I'll put that there, which means blue has to go in the last spot. Cool. What's my next move? Green, blue, purple. Cool. What's my next move?
Well, that's it.
That's it.
Yeah,
Right. How do you know that's it?
because you've gone through all of them.
Because if you've exhausted every possible.
Right. If I do it systematically, I should end up with the same start number of stuff. So purple has 2, blue has 2, green has 2. Right, they've all shared equally. Great. If I try to change the first thing again, I have to have ended up on one of the other ones. So I know that I'm definitely done by that. Great. So in short, that answer is 6, right? Which I think Riley said, but I can't remember.
No, I didn't.
No? Oh, Aaron, good job. Is that a question or no?
No, not anymore. I'm good.
Alright, yeah.
Going by that, can you necessarily say that when you hold up 3, you can say which color goes up first the most, like how many times? So if they go first, they can only go first a possible of twice. So you count that for each color, and that's what you mean by location and color. So it's 2 plus 2 plus 2. I mean 2 times 2 times 2, which gives you 6.
Which gives you 8.
Wait.
You're playing with good ideas, but again, we're stumbling into,
Is it
smashing puzzle pieces.
Is it the total minus 1 times what's left? So you've got 3 markers, you minus 1 marker, and then you times it by 2. So then, so with 4, you would have a total of 12
No,
combinations.
no. You're playing with the right things because you're getting good multiples, but no.
You don't add them together. Because 2 plus 2 plus 2 is 6. And that's how much.
That happens to be true in this case, but that's not why. It's the same as saying, I don't know,
Because it's like.
I don't know how to do it. Oh, it's like saying 2 to the power of 3 is 8, because if you take a 3 and then take a second 3 and turn it around the other way, it looks like an 8. It's like, I mean, that works, but it's, no.
I'm gonna guess the next one's 12.
I'm going to guess the next one is 12.
Well, with the red included.
Pretty sure.
With the red included, okay. Do you want me to give you a minute to try and do it with red?
Wait, oh, hold on. Sorry.
Take it, see how you go. You may or may not stumble across something really quickly or really slowly, or totally start it up, there's always an option. DJ with his fingers.
Using my toes as well. I see what you mean. But my way down the way.
Ah.
Got a number or no? Yeah, okay.
You're gonna have to really figure out one.
You're generalising. See if you can think through what the next one has to be. Like as in if I have, I don't know, whatever colour, pink.
Yeah.
Yeah.
One.
Wait, what's the answer to it?
I'm not gonna go, I don't want to ruin the surprise just yet. Aaron's got an answer or no? Yes?
I have an answer.
You have an answer? Okay. Cool, so Leslie's scribbling, so he's organising his thought.
I did attempt it, but Zach's got something.
Zach's got something, okay. Alright. You want another second, Celestia, or you close to it? Finished? Okay. Cool. Alright. Does anyone want to tell me what their number was?
24.
24, 24,
24.
24. You guys? Zach?
24.
24? Okay. 24 seems like a pretty good consensus, and yes, it is 24. Out of curiosity, did you do 5 as well?
Right now.
You do? Okay. So you haven't quite generalised to the super quick way yet. Alright. So you've got a method. That's methods. Eventually you can check those out. Yep.
Oh, can I just say what I thought?
For the 4 thing or for the 5?
It's like, are you going to explain it or?
I will, but you go nuts.
I just thought because, like I'm thinking with the 3s, it's like replacement, right?
Yeah.
Yeah, so with the foods, you are technically like replacing. So you have the 4 and then the 2 and then the 3, but with the numbers, you're getting rid of it, so it's 3 and then 2 and then 1. Yeah.
Perfect. Okay.
So with 4 it would be 4, 3, 2.
Right. Now, here's a curious thing. Did anyone else follow what he was saying at all? No, right. I understand what you're thinking, right? That wasn't exactly the best wording in the world, but what you're thinking in your head is good. Don't lose that. That's good. I'm going to try to refine that one play. Alright. Well, let's think about this in a slightly different way. If I've got 3 textures, or 3 markers, whatever, I can think of that as, okay, I've got 3 places to put the markers. Okay. So I've got 1, 2, 3 spaces. Okay. How many choices do I have for the first placement? 3. 3, right? I could put purple, or blue, or green. So I could have that. Great. How many choices do I have for the second placement?
2.
2, because I've used one of them, right? Okay, that. How many choices do I have for the last placement? 1. Okay, so I had blue or purple or green, so all's meant plus, so those are my options in the first thing. And then multiply my options in the second.
6.
And
6
then-
times 4. Because your times in all there by 4. 3 times 2 is 6, 6 times 4 is 24.
Oh, for the 4 section, yeah. So this gave me the 3 section, great. What's the difference with this? Well, now I've got a 4th option. So I've got 4 options originally, and then 3, and then 2, and then 1. Cool. Okay, great. So, if I had 5,
5 times 4 times 3 times 2 times 1.
Right.
Oh,
Okay.
okay.
Which ends up being
98.
90,
120.
120.
Your method didn't quite work.
What was it, sorry? 98.
120 you should get. Great. Okay. Well, what if I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 markers?
Wait, wasn't it?
Can I work
24 times 5.
24 times 5, yeah.
What did I say?
You said 98. Definitely one thing.
I probably,
Okay.
I probably.
Alright.
Doing 5 times 20 is 100.
How many do you have?
I have 10 markers.
Can I use a calculator because that doesn't take too long?
Okay. What are you going to do?
10 times 9 times 8.
10 times 9 times 8 times 5. Right. So, it would be handy if we didn't have to write 10 times 9 times...
Oh, your method.
Right. Oh, kind of. So, rather than writing this, because that's getting a bit tedious, 4 exclamation mark or exclamation point.
I remember that.
Right? Do you remember what it's called?
No.
Oh,
That's what it does.
Factorial.
Factorial.
I remember learning
We did this last year.
Yep. I know we did it last year, I was there.
That makes sense.
Yeah, it does.
I didn't-
So, factorials, right? Just gives us a faster way of writing whatever times whatever times whatever. Cool. So, if I had, let's go this way around, n factorial. So n is just some number. Okay, what's the first number? N.
And it's
n times n minus 1.
and n minus 2.
Right, where does this go?
So infinity.
To infinity?
No, 2.
Right, it keeps going until n equals 1, yeah? So this will times and just keep going until I get 2 times 1 at the end. Okay.
What do you mean 2 times 1?
So assuming that n is bigger than 2,
You.
right, it'll keep going down the chain until eventually it ends in 4 times 3 times 2 times 1.
You.
Yeah? That's all I mean by times 2 times 1.
You.
Good. If you wanted to, you could rewrite this as n minus 1 and then times n minus, wait, is that right? No, n minus 2 and then n minus 1. But that gets really ugly, so it's just easier to simplify that and say that's 2, that's 1.
You.
Okay. Yep. Oh, stretch. Cool. Alright. So, that's factorials. Brilliant. There we go. Okay. Well, that's what we call a permutation. It's a very simple permutation. So now, we're going to be more annoying. So, what were my colours? Purple, blue, green, red. That's wrong. What did I do? Wrong. No, wrong. Red. So, got my same original 4 colours. I only want to pick 2 of them. So I've got 4 options, but I only want to pick 2. Okay. So, pick a 2.
There's going to be a tree diagram. Then we'll do a tree diagram.
I mean, you can do that if you want.
I don't want to do that.
You don't want to do that either.
You have a better option.
I'm pretty sure we've done this in 8.
Well, I pre-method last year.
Yeah, in pre-methods last year I covered that same line of thinking, which is why I was hoping that that would be pretty intuitive by that point. But anyway, sorry, what did you say?
Just with positions or just...
Okay, so you're asking good questions here. So, I've got these 2, right? Basically these 2. I've got these 4, I want to pick 2. Right? And I'm going to say that is different to that.
What?
Oh.
Okay, so in other words, if I pick purple then blue, that's different to picking blue then purple. Okay? Yep.
Can you,
That actually makes it easier.
can instead of working it from there, can you work it from the 24 combinations that you have?
You could,
Would it take longer?
probably.
Because like,
It depends which way you use. If you use a super fast way, that definitely takes longer because you wouldn't touch the 24 in the first place. But, Yeah. Anyway, there's faster ways to think about it. But let's see if we can just think that through. If I pick any two and the order matters.
Is it 12?
Okay. Hang on, what is it? Yeah, 12. Yeah. Yeah. Cool. All right. How did we get 12?
Just followed the same method as before. So
Right, use the same idea as before, right? Rather than think about anything else, just go, okay, I've got two spaces that I have to fill. Okay. How many options do I have for the first space?
4.
How many options do I have for the second?
3.
Cool. And this, and then this.
Oh.
Is that all? No.
That's it.
But what would be the differences if purple and blue was one match?
Purple and blue and blue and purple were the same thing.
Yeah.
Cool. Then we get into combinations as opposed to permutations,
Which we're touching next.
which we'll get that. It's all good. All right.
So that should be 24.
I'll think about it when we get to it. Okay. Pick any, let's say 4 from the whole set of 10. Pick any 2 from 4, pick any 2. So, what do you get?
10 times 9 times 8 times 7 equals stupid number.
Whatever it is. 90 by 56. Whatever it's so
Oh, I have a question.
Yep.
So you know how it goes 4 times 2 times 2 times 1, and that's a 4 to 4 factorial.
4.
Say again?
You know how it's 4 times 3 times 2 times 1, and that equals 4 factorial.
Yep.
Right. If it was like 10 times 9 times 8 times 7 times 6 times 5 times 4, and then stops, what do we do then? Is that still?
You're so good, TJ. You are reading my mind as to what has to go in here. Well done. Alright. So, okay.
What's the name of the thing?
Oh, is it? Oh, never mind.
Oh.
Any from here?
So keep in mind here we have.
So it's just m minus 1 times the amount of n. Like that process n times.
Say that again.
Isn't it just m minus 1? And you do that n times. Or until you reach.
Oh, is it n minus 1?
I'm going to change these letters
And
because M and N is too similar. Alright.
X and Y.
Any A from B. Okay. Say what you're saying again.
it's like b minus 1, and that process happens 8 times.
Or is it 8 minus 1?
Why B minus 1?
Because if you start at how many options, right?
Yeah.
You start at b,
Yeah.
and then you minus 1. Then you use 1. You use b.
Oh, sorry. So you said B times B minus 1 times B minus 2. Is that what you said?
Ah yes, that's right.
Okay.
That's right. Yeah.
Cool. So we've got A spaces. Yeah.
Yeah. And then
This is going to be
b times b
B
minus 1,
times B minus 1. And that's bracketed.
then times b minus 2.
Yeah.
Yeah, so I didn't say times at all.
Alright.
And then that happens 8 amounts sometimes.
Beautiful. So we've got a method that works if we know the numbers.
Yeah.
What if we don't know the numbers? Well, then we don't know how many times to do it.
Can we do b times b minus 1 times 8?
Why add?
Because or times how many times we're supposed to do it?
Right. But then every time you do it, the number changes.
Oh,
Yeah. Okay. So this becomes a little bit fiddly. It's like, oh, we've got a system, but we want to be able to generalize the system so that we don't have to know what A and B are, so that we can just have a formula to run with. Okay. May I propose this is 4 times 3. Now, if it had times 2 times 1, that would be 4 factorial. Right?
Yeah.
Great. Well, what we really need then is to just divide this last bit off. Well, that would be 2 factorial. Okay. Well, what happens here? Well, that's 10 factorial, but we need to remove 6 from down. Yeah? Okay. Just to give another example, because it looks like now, let's go pick any. B.
Do B factorial.
Let's say pick any 6 from 9. One, two, three,
N factorial
Six.
divided by
9, 8, 7, 6, 5, 4. So in red, what am I going to write?
9 factorial divided by 3 factorial.
Cool, alright. Do we notice a pattern?
B factorial divided by B minus A factorial.
Say that again.
B factorial divided by B minus A factorial.
Perfect. That bottom one is the difference between the A and B. Because if we're using up A, well then we've got whatever is left over, which is B minus A. So that's all we have to get rid of at the bottom. Cool. This is permutation. This combination of this is how many? That's combination. What's wrong with it? Jeez. Yeah, it's permutation. Combination has the other bit on
So what's
yeah.
that called?
So this is permutations of. Now I'm going to change these letters so that it's. Oh, why didn't I just do that in the first place?
Because it sounded wrong.
Foolishness. Cool. So this idea is what we call permutations, and there's a shorthand notation for it because this is obviously getting a bit clunky. So n factorial over n minus r factorial is superscript n, capital P, subscript r. So back here, so this would have been whatever it was, 9p6, 10p4, 4p2.
Would that be 4p2 equals 4 times p equals 4?
Yeah, all these.